Here is the homework key. Hopefully it helps you. Those of you who are watching, thank you very much. Alright, a regular polygon with 3 sides, we just call that a triangle. A regular polygon with 4 sides, we call that a square. With 5 sides, it is a pentagon. 6 sides, a hexagon. 7 sides, a heptagon. 8 sides, octagon. 9 sides, we call it a nonagon. And 10 sides, we call it a decagon. So those are the names of the regular polygons. Next page. It says draw the lines of symmetry. And again, the number of lines of symmetry always matches the number of sides. Triangle has 1, 2, and 3. Square. 1, 2, 3, and 4. Pentagon. 1, 2, 3, 4, and 5. Hexagon. 1, 2, 3, 4, 5, and 6. A heptagon has 7. Let's see if I can do this. 1, 2, 3, 4, 5, 6, and 7. Octagon will have 8. 1, 2, 3, 4, 5, 6, 7, and 8. So n sides has n number of lines of symmetry. Diagonals on the inside, remember, a little bit different. A triangle has 0. This does not count as a diagonal. A square has 2. 1, 2. A pentagon has 5. It's the only regular polygon that has the number of diagonals equal the number of sides. 1, 2, 3, 4, 5. The rest do not match the number of sides. This is a 1, 2, 3, 4, 5, 6. 6-sided. 1 diagonal. 2, 3 diagonals. And are there any other diagonals? Yes. 4, 5, 6, 7, 8, 9. I believe that's it. And you can see the pattern. Looks like the pattern goes up by 2, then it goes up by 3, then it goes up by 4. I bet the next one goes up by 5, next one goes up by 6, and then n will come up with a formula. So I bet 7 has 12 diagonals, 8 has 18 diagonals. Let's use the formula to double check. So n equals 7. Plug into the formula. Gives me 7 times 7 minus 3 over 2 7 times 4 over 2 gives me 28 divided by 2. That is 14. Yes. Oh, that should be 12. Let me see. Going up by 2, going up by 3, by 4. Oh, I'm sorry. I added that incorrectly. 9 plus 5 is 14, so that was accurate. Sorry about that. And then 8 should be 20. Let's double check. That 8 has 20 diagonal. So plug in 8 into that formula. Gives me 8 times 5, which is 40 divided by 2, which is 20. Let me see if I could try to draw some of the. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I lost track. So these bigger ones, it's best to use that formula n times n minus 3 divided by 2. And then again, that formula will go right here. N times n minus 3 divided by 2. Alright, next page. I'm going to show you on the document camera how many times this touches itself in one rotation. So here it is. I drew it. I traced the edges. I put an indicator arrow at the top to see how many times it will go around. Let's count the order of rotation. Order. 1 on itself. 2 on itself. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The order of rotation is 12. It touched itself or covered itself 12 times in one full 360 rotations. So let's go back to the math. With that, in order of 12, order of rotation is 12. The order of rotation always matches the number of sides on a regular polygon. To find the angle of rotation, I take 360 degrees and divide that by 12, and that will tell me the angle that I'm going from one spot to get to here. That will give me this angle in degrees. So if I take 360 divided by 12, goes into 36 3 times. Bring down the 0. Goes into 0 0 times. That is 30 degrees. So again, every time I turn at an angle of 30 degrees, it covered itself up. So the angle of rotation is 30 degrees. All right, get this done. Show me tomorrow.